Okay, so again, do not graph anything yet, please. I just want you to look at the two inequalities that I made. So when you did your exploration, one of the first questions I asked in there was, how do we know if the line is going to be solid or dotted? So what about the inequality makes it either a solid line or a dotted line? Go ahead, Grace, what do you think? Right. So yeah, same thing Raphael just said too. So if there is a line under my inequality symbol, then it is going to be a solid line. If there is not, then it is going to be a dotted line. So just looking at that first inequality, what type of line is that one going to be? Yeah, a dotted line. If we were to graph it, where would we start? Where would our first point be? Jemiah? Be more specific. You're close. Zero, 6, are you? Yeah, 0, 6, good. So 0, 6, and then what we do from 0, 6? Yeah, Bria. I would do what? Okay, at 0, 6, then what? Do you know what you would do after that? So you'd go up 2 and then right 1 to put our second point, and then we'd make the line. Okay, last question before we actually graph it. How do we know which side to shade? What could we do to test to see what side we should shade? Cole? How do we know? So if I draw the line, right, the dashed line, how do I know, since it's an inequality, I have to shade on one side or the other? What would be a good way to see where I shade or how I shade? We did do this on Thursday, but I might need to refresh your memory. So you get to pick any point. What did I say was the easiest point to use? 0, 0. So if we substitute in 0, 0 to that inequality, does it make a true statement? Is 0 greater than 0 plus 6? It is not. So that means when I shade, I need to shade on whatever side of the line that does not include 0, 0. So you'll look when I graph it. Here's my line that goes through 6 and goes up to right 1, and it's dashed, and it's also shaded on the side that does not include 0, 0. Any questions about that? Okay, I want you to go ahead and graph just the first line on your Desmos. If you need the inequality symbols, obviously you can use the one on your keyboard, but if you hit this little keyboard button in the bottom left, it gives you like a bunch of different options to type in. You're just graphing that first inequality. And then just for fun, in case you want to use it, if you hold down this blue circle, you can change the color. If you click and hold, you can change the color of the line if you want to do that. Mine looks what?
Mine looks different.
How so?
Oh, never mind. Wait.
I've also like shifted where my window is. Maybe that's why.
Oh yeah, you're more zoomed in.
Yeah. Yeah, you should be able to like click and drag around the graph if you need to do that, or you can, yeah, change the colors, whatever you need. I usually try and stick with like red and blue because then obviously I know that their shaded part that they have in common makes a purple one, but you can use whatever you want. Okay, so let's look at the second one. Again, before we graph, let's talk about it. So what kind of line is it going to be? Solid, and we know that because of the equal to. When I graph, where would I start? 0, 2. Yep, 0, 2. From 0, 2, I would go down, not to -3, down 3, and then right 1. Okay. And then last question, we got to pick a point. So I'm always going to encourage you to use 0, 0. So if I substitute in 0, 0, I'll show you, Carson. When I substitute in 0, 0, does it give me a true statement? 0 is less than or equal to 0 plus 2, right? So that means when I shade, I need to shade on the side that does include 0, 0. Carson, if you hit the little keyboard in the bottom left, you'll see that there's a greater than, equal to, less than, equal to down there. So go ahead and graph that second equation, and it should look like mine. And you'll see that in that blue area, 0, 0 is covered because it is part of our solution. We don't want to shade on the other side. Okay, so when you were doing the exploration, we now have a different area that's the solution of both. So the solution of both is anywhere in that like purpley area. So what would be a point that would be a solution of both of those inequalities? There's an infinite amount. Just give me one example. Yeah, Mackenzie.
Negative 2, 2.
Negative 2, 2. Now I want to talk about negative 2, 2 actually. Where does negative 2, 2 fall on? No, it's really important that you said that. Negative 2, 2 falls where?
On the line.
On what kind of line? A dotted line. So that is not allowed. If it were on a solid line, I would say yes, but since it's on a dotted line, so fix yourself. What would you say?
4, 2.
Negative 4, 2. I agree. Negative 4, 2 is in that area that they share. Yes. Negative what?
16.
Yeah, negative 16, 5. Grace?
Negative 2, 4.
Negative 2, 4 would also work. Negative 1, 5 would work. Because what kind of line is negative 1, 5 on? A solid. Remember, you can be on solids, you just can't be on dotteds. Does anybody have any questions about this graph before we look at a second graph? Okay, so now what I'm going to do is I'm just going to show you a graph, and I want you to try and come up with the inequalities that make that graph, okay? So I'm going to put a graph up here. I'm going to hide my inequality symbols, and I want you to try and come up with the inequalities that make that graph. Okay, so here is my graph. I want you to try and figure out what the two, and you can type them into your Desmos and edit them as you see fit. Change what you need to change. I want you to make two inequalities that match my two. 116. Digital students, if you have your Algebra Nation book, keep Desmos open because we're still going to use it though. And then you need to be on page 117. Okay, so Juan must purchase car insurance. You guys don't drive cars legally yet, but whenever you do someday, you have to buy car insurance. Does anybody know what car insurance does? Yes.
It like, so if you get in a wreck or your car breaks or whatever, you get money back.
Yeah, so like if you get into an accident, especially an accident that's not your fault, your insurance will pay for it. Like, so you pay them like a little bit each month so that like if something like that happens, they will give you money for it. So you don't have to like pay a whole bunch of money to fix your car. It also protects yourself too. Like if I get into an accident and like hurt some part of my body, insurance will help pay for like if I have to go to the doctor, if I have to get surgery, all that kind of stuff. So important stuff. You probably have insurance like to go to the doctor, like your parents pay for your insurance most likely. Same thing, it's just insurance for a car. Your house has insurance too, because what could happen to your house? It could burn, it could flood. people could break in, right? You have insurance for things like that. Yeah, exactly. So Juan must purchase car insurance. He needs to earn at least $50 a week. So you'll see that that's represented by that greater than or equal to. He needs to earn at least that much money. The most he can work is 8 hours. So you'll see in our second inequality has a less than or equal to, because at most means that amount or smaller. Juan can earn $10 per hour mowing lawns, yards, and $12 per hour washing cars. So they made our two inequalities for us. The first inequality is how much money he's making. The second inequality is just dealing with the hours that he's working. So we have a money inequality and an hours inequality. So for this one, since they already made the inequalities, let's tell me what the variables are. So what does X represent here? Yes. Yeah, hours mowing lawns. So what would the Y represent? Yeah, hours washing cars. So they were nice and graphed this for us. And you'll see that there's like a little parallelogram. That's not a parallelogram, quadrilateral. I know my shapes over here. Where it shades between the two inequalities. So any point in that little sliver in the middle counts as an amount of mowing lawns, amount of washing cars. So what is one scenario that falls in that little sliver? Yeah, like a coordinate point, exactly. Yeah. 4-3. 4-3 falls in there. So that means that he's spending 4 hours mowing lawns and 3 hours washing cars. And that is going to give him more than $50. What's another option that Juan could do? Jemiah? 6-1. He could spend 6 hours mowing lawns and 1 hour washing cars. What else? Grace? 2-6. 2 hours mowing lawns, 6 hours washing cars. Mackenzie? 2-5. He could also do 7-0. Maybe Juan hates washing people's cars. I hate washing my car. I would rather mow lawns than wash cars. He also gets paid more. So he can do less hours and get paid more money. That sounds like another thing that I would want to do too. Okay. So all these options. Is there an infinite amount of options? No. Because he, as far as I can tell, it just says whole hours. He's not getting paid for half an hour. Maybe he does, but we don't know that right now. But just the whole numbered options would work. It is a limited amount. Okay, good. So let's try another one. This is where we're going to end up using Desmos. So just make sure that that's open. We're going to skip the let's practice. We're going to jump over to the try it. So the try it says, Anna is an avid reader. Her generous grandparents gave her money for her birthday, and she decided to spend at most $150 on books. Reading Spot is running a special. All paperback books are $8 and hardback books are $12. Anna wants to purchase at least 12 books. So first, we're going to say X is going to be paperback and Y is going to be hardback. So just money alone. How can I represent her situation by just talking about how much money she's spending? So it would be the first thing. Yeah. 8X. Y. Yep. not equals. So she can spend at most $150. Opposite, less than or equal to. Yeah, you had the right direction, just the wrong name. She needs to spend less than or equal to. So at most means you can only spend up to that amount of money. If $150 is her budget, right? She doesn't have more than that much money, so she can only spend up to that much money. So that's her money. The second inequality deals with the number of books. So she wants at least 12 books. So if I add her books together, X plus Y, I want that to be greater than or equal to 12. So that's how we're going to separate the two inequalities. The first one is dealing with the money. The second one's dealing with the items. So if I add the two amount of books, I need to get bigger than 12. If I add the two amounts of money, I need to be less than 150. Yes.
So basically, the second will always be X plus Y.
A lot, I don't want to say always, because that's kind of, I run into issues saying, but a lot of the times, yes. Yes. And you'll notice in the first one, the inequality symbol was the opposite way because he couldn't work more than 8 hours, right? And this one, she wants at least 12 books. So that's why it's flipped over the other way. Okay. All right. So I want you to graph. We're going to graph those two inequalities in Desmos. So go ahead and open your Desmos. We have 8x plus 12y, is less than or equal to 150. And then we have x plus y is greater than or equal to 12. Should make like a little triangle area where they intersect. It's an interesting singing voice over there. Okay, so keep your Desmos open. I'm pretty sure everyone that I see has it correct. You may need to like zoom and scroll around a little bit. So in your book, we're going to skip the graphing piece. We just graphed it in Desmos. We want two different solutions for Anna. So look at where the shadings like overlap. What is one possible combination of paperbacks and hardbacks she could buy to obviously spend less than 150 and still have over 12 books? So you're looking in the little triangle. What's a point in that triangle? Yeah, Mackenzie. 10, 5. So that represents 10 paperback and 5 hardback. What's another option? Grace? 6, 8. So 6 paperback, 8 hardback. Lena? Ooh. Where are you going to buy -5 books, Lena? Yes, is that in the shaded area. Yeah, but remember, we're talking about what? We're talking about some books. I'm going to buy positive books. Jemiah? 12 paperback, 2 hardback. Bria? 13, 4. 13 paperback, 4 hardback. Eric says 13, 3. 13 paperback, 3 hardback. One more, Lena. What you got? 7, 2. 7 paperbacks, 2 hardbacks. Is that in the shaded area? Are you sure? Are you sure?
Yeah.
Because that's not 12 books. Is that where they join? Like 7, 2. That's not in my. Did you may have mistyped. So you should have 8x plus 12y is less than or equal to 150. You got that? And then x plus y is greater than or equal to 12.
Oh, I put 2.
Oh, that's why. Now, Lena, give me an example besides 7-2. 15-1, yeah, 15 paperbacks, 1 hardback. We could sit here forever, kind of. Is there a limited amount? Yes, because just like Lena, we're not going to go buy negative books. We also can't go to the bookstore and be like, can you give me 0.2 of that Harry Potter book, please? They're not going to do that. You can only have those positive books. Yes. What's up? Yes, there is. No, if you remember on the exploration, it kind of cuts the graph into 4 pieces. So like just the red, just the blue, the purple, and then there's a space where they're neither graph was. Do you have a question, Grace? Or are you good? Okay. All right, let's look at one more problem and then I'll give you guys the rest of the time to work on your homework. So this one's already graphed for us. You'll see similar, Bria. So like the bottom little like the bottom triangle is our like white space here, okay? So their solution area is at the very top, right up here. Oops, let me use a highlighter, not a, where the shadings intersect with each other. So that all the points in that area, and if I were to zoom out like Cole was doing earlier, like zooming out as far as he possibly can, that area would get bigger and bigger and bigger, okay? So we want to see of these 12 coordinates, which ones are inside that shaded area. So let's look at the first one, 8, -8, 3. No, -8, 3 is in one of the shaded areas, but it's not in both, so we can't underline that. What about -3, 8? 1, 2, 3, 4, 5, 6. I think it's in that area. -3, 8? Yeah. What about -1, 9? Yes, that is. What about -4, 9? Yes. What about 9, bless you, 6? No, 9, 6 is only in one of the shaded areas. Okay, 0, 9. This one I want to talk about. Yes, because what kind of line is it on? A solid line. You're allowed to be on a solid line. You just can't be on a dotted line. 5, 5. No, 5, 5 is only in one of the shaded areas. What about -5, 10? Okay, so we're split. Who's, is it? Is it?
No, which one's 10?
I would just count to -5, 10.
Oh, the 5 is on the 4.
Yeah, so -5, 10 is why I want to talk about this one too, is on a dotted line. Remember, dotted lines don't count, so no. What about -9, 1? No. What about -2, 7?
Yes, it's on the line.
It's on a solid line. 1, 6. No, 1, 6 is only in one shaded region. Easiest point on the graph, 0, 0. No. So the only ones that were there is -3, 8, -1, 9, -4, 9, 0, 9, and -2, 7. You thought it was going to be what? Oh, no, not necessarily. Okay, last thing, because I know some of us want a little bit of practice. Let's look at part B. So we want to make the inequalities. I just want you to look at the solid line. Ignore the dotted line. So we know we need a y, we know we need an x. So what is the slope of that solid line? What is the slope of that solid line? It is 1, 1, or 1 over 1. So y, and then we're gonna have 1x, And then where does that line cross the y-axis? At positive 9, correct? So that means I'm going to have plus 9. Now, we need to decide which way is my inequality symbol going to face. So is 0, 0 in that shaded area for just the solid line? It is not. So I need to make sure that 0, 0 is not an answer to this inequality. And for it to not be an answer, it would need to say greater than or equal to. If it said the opposite, then 0, 0 would be an answer. We need 0, 0 to not be an answer. And why is it an equal to? What kind of line is it? Yeah, a solid line, exactly. So let's look at the dotted line. Why? What is the slope of the dotted line? I think it's -4. Double check me on that. I'm pretty sure it's -4. So remember, my slope goes in front of my x. Where does the dotted line cross the y-axis? -10. Okay, is it going to be an equal to or no equal to? No equal to. So then let's decide. Is 0, 0 part of that shading? It is. So that means I want 0, 0 to be included in this answer. So the correct way to do that would make it a greater than. Because if I substituted in 0 for y and 0 for x, I would get something that's true. Another way that people think about which way to flip the symbol, and this is just an alternative way of thinking about it. This first shading was above the line, so it was a greater than. The second shading is also above the line, so it was a greater than. If you want to think about it that way, that's fine. Sometimes that's a little bit confusing as far as like talking about above the line or below the line. So what I mean by that is, like, if we went back to the first one, this line right here, remember he wanted to work less than 8 hours, so that's why it was below that, but he wanted more than the $50, so it was shaded above that line, and their shadings join like between the two. So however you want to think about it is fine with me. But those would be the two inequalities for this graph. Y is greater than or equal to 1x plus 9, and y is greater than -4x minus 10. Yes. For the dotted line, because it goes down and to the right.